Very good morning. Today's the next topic of your fifth unit is nothing but current meter. This is Dr. Rahim from Associate Professor from MJCT. So the topics today I'm going to cover is nothing but definition of your current meter, PMOS current meter, NMOS current meter, so degeneration current meter, cascode current meter, and Wilson current meter. So out of this current meter, you will get source degeneration, cascode, and Wilson current meter one depth question for 5 marks. So actually come to the definition. What is the current meter? So here current meter is an analog circuit that copies the current from one device to the another. This helps to keep the output current constant even the load changes, the constant current. So the current meter is the basic building blocks for the analog signal IC. The output generates replicate of the input input reference current. So this is your reference current, this is your output. This is your current so control device kind of. So your output is nothing but output current is nothing but M of I reference. M is nothing but ratio between the both the currents can be equal, higher or smaller than. So this is your it's just mirroring of your current from output to the input. When you look at your like into the mirror, your replicate will be there. So same thing here, current replicate will be at from one device to the other device. That's what your current mirror. So this is more important device for analog switching IC. So how it works? The current mirror sends the reference current. So it controls the current in one another device to copy the reference current. The copied current will be same characteristic as the reference current. So this is your current mirror. The reference whatever they it will be copy it here. That is only. So that is going to help for the circuit for the IC design. So advantage of current mirrors is that they are simple to design and implement, replicates current accurately, compatible with analog IC circuit, cost effective, and can be integrated with other configurations too. So let us know we have two different types of current mirror. One is NMOS current mirror, PMOS current mirror. So the first one is NMOS current mirror. So this is your NMOS device, which is the bottom. So this is your current source of reference, and it will be this current reference will replicate across at this output of this transistor. How does this is a diode connector? The gate is shorted to the drain. So whatever the current is going to come across at this spot, and this current is going to having at this from this transistor. So this is what how going to replicate. The NMOS current mirror is this, and we had PMOS current mirror is nothing but the symbols when you look at this way NMOS and this is PMOS. So you whatever the current reference across hit here will be diode connected is going to come at here it was M1. So this is your M reference current is copying to the M1. So that is your ID1. So same thing, but PMOS will be upper and MOS will be bottom one. This is only the difference in your current mirrors. With the help of current mirror, we had seen that common source amplifier, current gate amplifier, and common drain amplifier kind of three difference. So these are the basic circuits of your NMOS and PMOS transistor. The input current is I reference, and output current is nothing but I. So that's what iot is nothing but equal to m into of I reference. M can be a large or smaller. So let us we had one more important cascode current meter. Hope this might be the asking your external examination. So the cascode current meter is nothing but the it's a current meter which is having similar solution for that, but we had transistor right here. This is your cascode amplifier. So cascode we can also make it in such a way we had advantage. So you had common gate amplifier and as well as common source. So both common gate and common source has been both the connected. So I can define cascode as common source followed by common gate is called as cascode. So this circuit is nothing but common gate, and this circuit is nothing but is known as common source. So this is a common gate, this is a common source. When this is diode connected which has been connected it here, so this part is your common gate, this is your common source. So common source is followed by common gate is nothing but cascode. The cascode amplifier with can be a current mirror is nothing but it can be a, like it is called just a plate kind of stuff. To increase the output resistance with the second transistor M2 in series of M4 is connected. The output resistance is nothing but R out is similar to GM R0 2 and R0 4. So we had minimum the input voltage of voltage. So but with help of effective voltage is greater than of your VTN. So when this is common gate amplifier and common source. So it is nothing but replacing of your source degeneration of current meter. So let us go for source degeneration. Before going, we had one more thing is Wilson current meter. So this is one of the circuit which is having the negative feedback, having the drain current as constant. So we had this topology is nothing but current series, current shunt series combination, shunt series feedback combination. So this is to keep your drain current as stable as series sampling output to increase and is used to output increase and at the output impedance. So in this connection, what happened due to the feedback, output resistance with the ROF increases with the 1 plus what is the feedback of negative feedback is nothing but AF equal to A by 1 plus A beta. So this Wilson current mirror has its own advantage of using this, and we had you can also use of this is the NMOS current mirror. With the help of this circuit diagram, we can see Wilson current mirror is negative topology which has been implemented. So next we had source degeneration current mirror. So this is your source circuit of source degeneration current mirror, and this is your RS. This is your RS. But to further increasing of your resistance, but this is called source. These two resistance are source degeneration. These two resistance source degeneration, and this is your current mirror. The whatever the reference of current is connected from your Q1 is diode connected is going to replicate at 2, and this is source degeneration resistance. So this source degeneration resistance has one more thing is we had this is your NMOS current mirror source degeneration, and that is a source degeneration NMOS current mirror, you can call it. This called SDCM. But RS his resistance takes more occupying the space, and to make very simple, we can you replace the source degeneration to the cascode amplifier, cascode current mirror, because common source can be followed with the common gate. It's known as cascode. So for this equivalent circuit for the small signal model is nothing but this. You had RS, this is source resistance, this is source degeneration resistance, this is your transistors of your small signal model, your 1 by GM and output, and the equivalent circuit of ROT is nothing but by the factor of impedance. ROT is nothing but Vx by IR. So RDS 1 plus RS GM2 plus GRDS2 is equal to RDS 1 plus RS in GM. But this RS can be replaced with the help of simple current mirror, and that can be used as cascode amplifier kind of. So that's all from this current mirror. Thank you. We'll look at next section with operation amplifier and as well as flash ADC. Thank you so much.